So what do I mean by that?
So,
Actual logic that's something over one. Something over
yeah. Guys, everybody. So if I had this, is that this?
No. No.
No, hell no. No. Integral of 1 over x squared plus 4x dx. Is that this?
No.
Yeah. Of course not. Hell no. No, so desperately not. What's the only form that becomes natural law? What's the only integral you can do?
When it's 1 over
Yeah, the
area.
only thing. The only form, notice how I'm saying it, the only form that becomes that is that. So what is missing from this? I could make this, if I replace 1 with something, I could make it become an ln answer.
2x plus 11.
I'm sorry, I said 4.
Oh, 2x
I'm
plus
with
11.
2x plus whatever the hell number you wrote down. Where did Christian get 2x plus 4 from? That's the derivative at the bottom. So if I let u equal this, du would equal that. dx, right? So if u is x squared plus 4x, du is 2x plus 4 dx. There's du. Some of you guys really seem to have no understanding of how u sub works. Notice I'm not calling you out, but I'm letting you know that you're not alone, for one thing. You just sort of reach and throw things in. It's got to make actual sense. It actually has to. So I let u equal this, so it's going to be over u, right? I have to be able to find du. I have to be able to find du in there. And if I find du in there, I'll replace it with du. I mean, that is du. There's no ambiguity. There's no, let me just put it there and hope. It's not. It has to actually, you're just substituting. You have to be able to find all the u stuff that you need in terms of x. So I need that in terms of x. I can replace that with du. That I can replace with u. And of course that would be what?
1 over u, du. Or
ln u. And so then I can say ln of what u is. What u do be. What you do be. What do you be? Alright, how are we doing so far there? Alright, so there are a couple of you guys that I hope to God you'll come to see me because you really don't understand U sub and how it's supposed to work. And it's not supposed to be a really crazy, difficult thing. It is very different. I'm sorry if that was supposed to stay there. Was that somebody's? Okay. As I'm erasing, like, oh shit, so that was left over? Alright. What am I trying to say? So some of you guys have, and I'm not going to stop you. I got my suggestion floating out there, and you guys are like, that's a nice suggestion, screw that, Jeff. And you just solve for dx, and that's fine. It'll work a lot of the time. But it will also lead you down these horrible paths. It's just so easy. Yeah. I'd much rather you be able to think about, what do I need to make this, right? So if I just put an x plus 2 up there, and the du requires this to be there, I can think, well, how do I make that become what I would need it to be? Put a 1/2 and then put a 2. Right? Now, if you solve for dx, you'll get the same thing eventually, but doing it that way just opens the door to making so many mistakes. You've got to believe me. People that come into my 280 class, want to teach 280, they were taught this way. They make all kinds of nifty mistakes because their brain says, I'm able to do everything because they can always solve for dx. But that doesn't mean shit. If you can solve for dx, big deal. You might not have what you need. And it just makes you get this false confidence. Oh, I can solve for dx and throw it in there and do every integral. No, you can't. All right, maybe. So most of you guys seem to have a handle on U sub. Little tiny mistakes here and there. Not a lot of people made huge mistakes. So if you are one of those people, you gotta come see me. U sub is stupid important. All right, any questions from the quiz? Any other questions? All right. Yes.
For mine, Okay, so I was just confused because, like, for the u part, it's 3y in parentheses 4th root of y minus 1. So wouldn't u be y minus 1? Right?
Beautiful.
Okay.
Which means y is what?
Y is just dy.
No. If u is y minus 1, y is...
Oh, wait, how can you solve for y? That's part of
Because... So everybody had a problem that looked something like this. Nobody had this problem. I like it. Right? Every one of you had a problem that looked something like that. Right? So every one of your problems are actually that problem. Right? They're all the same problem. So if I say, so it's pretty obvious u has to be m minus 5. Why don't I want to let u equal the whole cube root of n minus 5? Because its derivative is not in there. Now then you might start to argue, well, this guy's derivative is in there, right? What's this guy's derivative? dm. dm's in there, yay! So what do I have covered so far? I've got dm covered. I've got this thing covered. Shit.
Wait.
Do you see what I'm saying?
Yeah. But,
What?
okay, so you said you solve for y, but then do you take the derivative of y?
It doesn't matter. To be honest, I'm glad you reminded me of something. I want to read you a problem on there and show you. Somebody almost had a way that would work that's different from what I showed you. It doesn't always work. I want to show it to you. But I want you to realize, if I do solve for what? If I solve for m here, what's dm? D freaking u. I already knew that, right? I can do du, I can do dm. I don't care. I just need a relationship between du and dm. So it doesn't matter if you solve for u or m and then do the derivative. It's going to be the same relationship. Just solve for one or the other one. Does that make sense? It doesn't matter if I do solve for m. I'm not messing anything up because that is true. I'm just writing it down for myself. If u is m minus 5, then m is u plus 5. It's the truth. It doesn't mess up my derivatives. Derivative of m is derivative of u, no matter which way you look at it. But why? How did I know to do this? How did I know to do this? Because I got this freaking thing that's not covered by anybody. You guys got to analyze this. You got to replace everything with the original variable. You want to replace it with something about u, some function of u. So you just make sure you got everybody covered, right? So why would this problem be a lot more straightforward? What would you be? What's du? That is there basically, right? Just take part of that out. You with me?
Yeah.
So that's covered. That's covered. Everybody's covered. I don't have to do weird shit. I just did a quick little look. Is all the m stuff now going to be replaced by u stuff? Yes, you're good. Keep going. Is all the u stuff? Oh shit! I better do something so I can figure out what m is in terms of u. Now I've got everything. Now everything's covered. Everything's covered now. All the m stuff gets replaced by u stuff.
So then you plug u plus 5 into that.
Yeah. So I can take this one's easy. So let me take that out of here. Oh, yeah. All right. So now what's this going to look like? 4 times u plus 5 times the cube root of
U plus 5 minus 5.
u.
Oh.
I like it though, but it's still
I
u.
thought that was
d u, because dm is du, right? How are we doing so far? Okay. And now that's relatively u to the 1/3. You distribute. You can bring the 4 out. Right. That should be easy from there on out. Okay. All right. Let me try to remember. What was the? Let me remind myself which problem it was. Yes, it was that one. Oh, yeah. So it's sort of like this. Let me make it so that it's not the same. Sure. That'll work. Sure. All right. So this is kind of nifty. Now watch. This is totally. You don't have to do what I'm about to do, but it's interesting, and it sort of relates to what somebody asked me earlier. If I let u be, now watch. If I let u be 4th root of b minus 2, that seems like a silly thing to do, right? Totally seems silly.
Yeah.
But solve this for b.
U cubed or U to the fourth plus 3.
All right, so that's nice. So I got that covered. U is that thing. But then du, you're going to say, well, no. Well, watch. What's db?
Or you cubed.
4u cubed du, right? Now you got to be careful. I wanted to show you this. This does not work often. But there was one person that started going down this road and then stopped. I'm like, oh, that would have been so cool if you kind of figured out on your own some nifty, flexible. Was it you? Can't remember. No? But you're like, sorry, I don't want to call you out. Well, you should be happy about being called out on that. So then, what would this look like then? This is, B is this. You have 4 plus 2. 4 through to B minus 2 is U. But now watch, dB is 4u cubed du. I mean,
Wait, so then U times... Oh, wait, no, never mind.
see now that's relatively easy. 4u to the 4th, you distribute that through.
Yeah.
It's all polynomial, easy, right?
Yeah.
So that would work beautifully. How often does that work? Not a crazy amount of time. So it's not a method you kind of like make standard method. There's a standard method. No, it's not a standard method. But in Math 280, again, I keep referencing, in the first 2 weeks of Math 280, you're going to do something that feels sort of like this. When you do, I forgot what it was. When you do trig sub, it's called trig substitution. Oh. You have this ugly-ass equation, and then you throw trig formulas in there, and you're like, how's that going to make the situation better? And it does. So, bam, find out.
When does that not work?
When is what?
When does this kind of thing not work?
Oh, if this function was more ugly, you can imagine if it's not easy to solve for b. I mean, if I made it like this, and said solve for b, then you get to this point, and you're like, okay, solve for b. So it's not hard to make it not work. In this case, that actually did work because it's a nice linear function of b. That kind of approach actually would work.
This will work for anything we can solve for b.
Any linear function of b will any linear function of the variable, this type of approach might. Does that make sense? And don't you? If you really listen to what I just said, it was like half of the time it'll work. So that's why it's not like standard methodology that's taught. It's just these little flexibilities that are in U sub that you have to pick up kind of on your own sometimes. So that was really nice when I saw somebody doing that, and the person might have just been reaching, but that's what you're supposed to do. You're supposed to reach within what you understand how things work. You reach, and then you try something, you're like, holy shit, that actually did something. And then you hand it to me, and you're like, please tell me that was actually. Right? But that's the way, that's math. You just play within the boundaries of what you know. And sometimes you push it and you say, I don't know if that works, but let me just try it. Okay. Is there anything else from the quiz? What about from homework?
18. Not sure how do you show this one have 2 functions.
Where are we at? Sorry, section
6-3.
number 18?
Yeah.
All right, let's see. So this one says, here's the region. Number 18. Alright.
This is a shell?
Is this guy going?
Yeah.
Okay.
Yeah, using shells.
I always have problems when there's more than one function.
So, do we know integral d what here?
dx.
Dx is right, because discs would, this is parallel to the y-axis, discs would be dy, so this is going to be dx, because it's shells, right? We're using shells to tell me I have to use shells, so I'm like, alright, I'll use shells. So this region is the area bounded between these two, it's going to be rotated, right? So x squared, shwa! whatever sound effects are. And then 2 minus x squared.
The other way.
Now, does it make sense? I mean, you can see they meet at 1, right?
We're like,
When x is 1, they're both 1. So this region here, I should have done different colors. Let me see if I can backtrack. So you can really easily see who's where. That's the red.
the red sound.
Yeah. So this region here, about x equal to 1. So here's x equal to 1. So we're going to rotate it like that. So it's going to end up looking like a really weird shape.
Yeah.
Yeah, what?
Can you imagine it's like a big, beefy, and then in the middle it's really skinny. I mean, you guys see that?
Like
You rotate that around?
Tune being sort of thing.
Maybe not. All right. It's not required. Second. Oh, okay. It's not like a Klein bottle or something, but it's still freaky. And you don't need any of that stuff. So for shells, what do I have to do? What's the main look of it here?
Is
2 pi circumference, which I think is
circumference.
Which I think is 1 minus
The height
yeah.
and the dx of that. Cool. All right.
2 pi.
So I got to figure out what the radius is.
Is that
It's x
One minus
minus
that.
1.
So if I draw in, and how am I going to draw in
1
my
minus x.
yeah.
rectangle? So somebody had a good point. I didn't mean to say it in a strange way. You draw your rectangle parallel to the axis, but you locate it using the axis perpendicular to what you're rotating around. So if I draw in a rectangle, there's no representative rectangle. Is that cool? Because then I'm going to take that rectangle, I'm going to rotate it, and that would be one shell, one piece of it. And I like the images I gave you on the handout. They're the closest I can find that really shows you what it looks like if you do like a finite number of shells, some big old shells. Right? Sort of like going back to when we use 4 rectangles to estimate. 4 rectangles is normally horrible estimate. So this would be a big ass estimate, small number of shells to get a rough estimate. So here's what would this represent?
Yeah.
So what's my,
1 minus x.
yeah, and it could be here, there. So good, 1 minus, so this is x, so my radius is going to be 1 minus x?
Why is it 1 minus x?
I don't know.
Oh,
Why? Because this would actually be negative, right? So, for example, if this was negative 1, let's say negative 1/2. How long is this? 1 minus this.
1.5.
So it's always the big dude minus the smaller dude. You guys kind of with me?
Mm-hmm.
And x locates anything on the x-axis, and the big dude is the rotation axis, right? So it'll be 1 minus x. So how far should this one be? How far away should it be? What's this radius here?
2 minus 1.
2. 1 minus negative 1 is 2. So you can double check. It's a really good idea before you start doing any work. Make sure that the what you write down for the radius actually makes sense in some extreme situations or a few different situations. Give yourself some numbers. Make sure it actually works. So that's my radius. What's my height going to be?
2 minus x squared.
So what's on the top? Yeah, it's not just 2 minus x squared though, is it?
Is it 2 minus?
Because it doesn't go all the way down to the x-axis. It's 2 minus x squared
Minus
minus
x squared.
x squared.
Okay, sweet. I got that.
Let me stop there again. Right, it's the top of it minus the bottom of it. Just like the whole section finding the area between two functions. I subtract the functions because I end up subtracting the areas.
And then
So if I just did 2 minus x squared, that would be this whole. I got to subtract this little piece off to get just the area between the two. That's why it's the top one minus the bottom.
the main thing is it from 0 to 1. I wasn't really sure.
So let's see. Yeah, what's x doing?
Negative 1 to 1.
Negative 1.
Yeah, x is going from negative 1 to 1. I
But
think.
it's symmetrical.
Did we look at this one?
But
This feels familiar because somebody pointed out it's symmetry.
yeah,
So you can do.
from 0 to 1 times 2.
You just did what? Oh, you just showed it to me. Oh, that was where they did a lot of funky stuff. Yeah. Oh.
So
Anyway.
it's negative 0 to 1 times 2.
Oh, the related problem, because it wasn't the same problem, right?
No, different.
Yeah, okay, sorry. So, to do this officially, it would be negative 1 to 1, but you could do because of the symmetry. And this is why you should be really careful. Is it really symmetric?
No.
No, it's not. So you can't do that. You can't do what I was just saying, because here's the axis. Who's going to have the bigger volume? This region or that region? If they're the same volume, you can cut it in half and then double the answer. You can go 0 to 1. Are they the same volume? Think about it. This is going to rotate further out. Isn't it going to end up with more of itself? Doesn't that make sense? So is 0 to 1 the same volume as negative 1 to 0? No, because negative 1 to 0 is further from the center. It's going to go further. It's going to have more room to generate more volume from itself. Is that?
If it was rotated around the y.
Yes. We did a problem where it was symmetric. I can't remember which one it was, but you got to be really careful when it's when you're rotating around something that's not like in the middle or something. It'd be hard to. Why couldn't the rotation axis really be this? Because you'd rotate into itself. That gets weird. You don't want to occupy the same space as your own self if you've ever seen Time Cop. No, the Time Cops. Okay.
So I'm still a little confused why R is not this.
Yep.
All right, between the axis and the... Are you cool with this just being X? Is that cool? All right, good. So between the axis and this, how far apart are these? It's the bigger one minus the smaller one. Yeah, that's all. Always. There's almost no ambiguity there. Let it be really nice. So if I was rotating about this, if I was rotating about negative 4, it's the bigger one minus the smaller one. So then the radius would be x plus 4. Bam. Right? And again, just give yourself a concrete example. Give yourself an actual x value. Make sure that it works to what it's supposed to be. Make sure that it actually works. Anyways, that's not what it is. Okay, so we got to do this because it's not symmetric with respect to that axis, right? Right.
How do you know when to do that though? How come you don't do that with every equation?
I actually do. It's just that if I rotate around like a 0 axis, then then it would be like this minus 0, so it doesn't even show up. But I'm still doing minus 0. It's just like, why would I do that? So this would be, this was negative, whatever the hell, blah, blah, blah. It would be that minus 0. Right? Does that make sense? I mean, that's that. So if x-axis or y-axis is the axis of rotation, you're not going to. It's almost going to be too easy to even think. It's the minute I'm off of that axis, you're like, whoa, shit. Well, it's just not 0 anymore. Now it's 1, or whatever it is. Yeah. So now I just plug and chug. So now I got my 2 pi can come out. My radius is 1 minus x. My height is 2 minus 2x squared. And my thickness is there. Foil, integrate. No problems. Anything else from homework?
Professor, are we going to do anything with pyramids?
Oh,
That was back in section 6.2. They had a pyramid instead of a sphere.
oh, number 52, I like it. So, I don't know, did I sign that one?
I don't think so.
No.
Not on the other side.
No, I didn't sign it. That's, so don't worry about it, but
Because then you just change.
technically you should be able to do it.
I mean, it's not necessarily something impossible, but certainly.
It's not straightforward.
I guess so.
I give you that.
Yeah, it doesn't look straight.
It's not. Because you're like, how do I rotate something to get that, right?
Well, like it says over here that like if it has a square bar, you want to get it so that it's something that you know, like either triangles or squares or whatever.
Yep.
Couldn't you just, rotate it? No. That'd be a cone.
Alright, so let's not do that right now. We might talk about that later. Alright guys, any other questions from homework? Okay, alright. Do you want to do an example, or I could just... So then that's a question? Yes. 6-3? 42. 42 sounds more like an answer.
To every question.
To the question. It's just that they didn't know what the question was. Alright, so let's see. So here's what 42 says. 42 says, blah, blah, blah. It actually says that. Oh, okay. By any method. Ooh, you gotta like that. Blah, 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 blah. So let's see, x equals y minus 3 squared. X equals 4, that's the region. And we're going around y equals 1. I like it. Is that 4, Jim? Or is that y? You've already forgotten. 4. So if I draw this out, y is 1. That's one boundary. X is 4. I'm sorry, that's what I'm going to rotate. X is 4 as a boundary. And then what's x equal y minus 3 squared look like? Yeah, it's parabolic. And y, what is x0 and y is
3.
3. Alright, so it's going to be, let's see, this is 1. Shoot, I need to change my scale, I think. Oh well. 1, 2, 3, 4. Alright, see if I can make this work. So this is kind of like where the vertex is. And then when is x4? Yeah, how do you, so just make x4? Because this is my other wall here, right? So I want to see when do I run into that wall so I can really see what the area is that I'm talking about. So if I let x be 4 in this equation, I can solve. So I have square root, plus or minus 2. So y is 3 plus or minus 2, so I get 5 and 1. Let me make sure you guys understand. So when x is 4, y is 5. Or 1. So here's my parabola opening up that way. Scale sucks. My scale is bad. Jeez, Jeff. Alright, let's try this again. Horrific. Alright. So here's one wall. We found out that the vertex is there. At 4 for x, it's there and there. Okay, this is the area we're talking about. So we're going to rotate that ham piece around y equals 1. This is my rotation axis.
This isn't a shell, is it?
It's whatever method you want to use.
Oh, okay.
So the part of this is there a better method? Is there a method that works and the other one doesn't? If I wanted to use discs, and in fact, of course, it would be probably washers specifically, but it's still freaking discs, right?
Yeah, it's just.
It would be integral d what?
Yeah, dy.
What am I rotating around?
Excuse me, dx.
Something that's parallel to the
X-axis.
So it's dx.
Dx.
And what drawback might that have? But isn't really too bad of a drawback. Yeah, this is in terms of y, right? So we'll have to see if that's going to get drawn.
Plus or minus the square root of x plus 3.
Is everybody sort of with me so far? This is exactly, and I don't know, I haven't done this problem in forever, so I'm actually figuring it out as I'm explaining it to you, right? So everything I'm writing is me figuring out what's going on. So, if I do this, if I do discs, how would I start? Well, let's see, how would shells look? Let's see if shells, of course, would then be integral
dy.
It's, so I need functions of y inside. That already is a function of y, right?
Right.
So it seems like that might be nice, but you never know. So here, the first thing I would have to do is to solve that first one for y, because they need functions of x inside. But the nice thing with shells, normally shells, if it'll work, if the functions can be worked with to solve for the right variable, I'd rather do shells than washers. Because shells don't involve empty space, they just don't include it. Right? So let's see what the shells looks like. So this would involve washers, so let's see what shells would look like.
So the radius would be y minus 1.
Yeah, so I need
2 pi.
so let's see, I need the radius. So now I'm doing integral dy. I'm rotating this way. Where's a representative rectangle?
We have to
I like it. So draw it in the air for me. I like it. I like the way. Oops. Most of you guys are doing it right.
This
one.
Yeah. So it's going to be parallel. I'm going to rotate it around that way. So it's going to be like, here's a representative rectangle right there. Cool? Because then I'm going to rotate it around and make my shell.
Yeah.
I like it. I like it. So you draw them parallel to the axis you're rotating around. Well, why is it dy? Because how do I locate this
On the y axis.
on the y-axis? I like it. So what would the radius be? You start, so which one's...
Bigger one is
so what is this?
y.
Y. And what is this?
1.
1. Y minus 1. It's crazy. You guys see that?
Yeah.
Big minus small. Why make it difficult? If you read the book, I think sometimes you get a little convoluted explanations when it's really just, what's bigger? Oh, what's small? Right? It really is. So my radius is y minus 1. So whatever rectangle I'm at, how far away is it going to be from the axis? It's going to be y minus 1. I'm basically subtracting this 1 out from all my y pieces. Another way to look at it. Does that make sense? I heard a good sound over there. I like that sound. I was like, oh. So that's the radius. What else do I need? The height. So what's the height? What's nice about the height? This side is always 4. Alright, so and what's this side? So how tall is this going to be? It's going to be the top minus the bottom. 4 minus y minus 3 squared. So this is looking promising, right? Do you guys see that? And do you realize if I did, well, let's see. No, let's not go there right now.
Wait, why? How do we run square root of 4 and y is 4 minus?
Okay, so the height of this rectangle, what's the top?
X equals 4, yeah.
It's 4. How tall is it then? It's going to be 4 minus, because is it 4? No, it's minus this, right? It's not as big as 4. It's 4 minus whatever this is. I got to subtract this distance off, right? And what is that distance? What is this? What is the equation of this? Yeah, that's what x is. So x goes from y minus 3 squared to 4. So how tall is it? 4 minus y minus 3 squared. So yes, drawing in a representative rectangle helps you in so many freaking different ways. So my radius is y minus 1. My height is 4 minus y minus 3 squared. And yeah, what's y go from 1 to 5? I like it. So shells looks pretty straightforward.
Bam.
Yes, ma'am.
I'm confused about the 4 minus 1 minus 3 squared because, like, the r inner, r outer. Like,
No. That would be if I'm doing discs. Shells, there's no r inner, r outer. Shells is just how tall is that rectangle? How tall is it? It would be 4 if it went all the way down to here, but it doesn't go all the way down to there. It only goes to there. You have to subtract this much off, right? So it's 4 minus this, which is the y minus 3 squared. How are we doing? I'm not even going to do that because that's easy. And it's sort of busy work at the same time. It's so easy. FOIL, distribute, polynomial, integrate, easy. What would it look like for discs? Or, washers officially? Do you even want to look? Considering shells is pretty easy.
So,
Put a 5
I need to
just r squared.
get rid of stuff here. Let's see.
so when you rotate that, if you want to
All right.
pull a piece out, you have to find the radius of that piece.
So if I wanted to do
And you have a shell.
discs, everything's got to be dx for one thing. I have to solve that.
And you just
And-
add whatever you need.
then we see the immediate problem. If I try to solve that, let me see. What am I trying to go? Well, I'm in a region. Well, let's see if you guys get this. If I try to solve this for, try to solve this, what happens?
So the square root of plus or minus the square root.
Yeah, plus or minus square root of x. Right there, I'm going to go. I'm not going to do it that way. And you guys see why this is happening? Because, see how I'm going to draw this. Oh. So see how our inner would be between these two, right? So from the radius, from the rotation axis out, our inner would be this. Our outer would be that. So our inner would be the negative rad x plus 3 blah blah blah. And our outer would be the positive rad x plus 3 blah blah blah. Right? So it wouldn't be impossible, but it's starting to look, shells is really easy. Right? If I start to set this up, and I'm like, ooh, I got to solve that. If I catch myself saying something like that, I'm like, well, let me see what this would look like. Do you understand what I'm saying? I mean, that since the method was open to me, I could use whatever method I wanted to. I thought shells would be easier, possibly, just because I didn't have to solve this for anything. Shells dy, it is a function of y. All right, let me start there. And then I'll see if I run into something like, oh shit, that would be gross. And then I might go over here and say, let me see what this will look like. And this is all part of the process. You're not supposed to know right off the bat the right process. You're not supposed to. You're supposed to do something wrong. It's not really wrong. You're just like, oh, that's not the way to go. Let me go the other way. All right. So don't freak out if it happens. If you're like, oh, that's ugly. Oh shit, what am I doing? I don't know anything. No, just do it the other freaking way and see how it looks the other way. All right. Anything else for homework? What time is it? Ooh. All right. I got 5 minutes. This is nice because this is quick. I just want to chop off, finish off chapter 6.
So are we going to actually do some work? No, I'm just kidding. That's the next chapter. Or the next section.
Well, we're skipping 6-4.
Oh, we are? Oh. So we're not going to do any work.
No work.
Sorry, man. That's too bad.
So we're getting a good version for no work. That's
Hey, that's better.
Alright.
Like your phone.
If I told you... So if I told you, this is going to be a really strange question, but a remarkably simple question to answer. If I said that the area of a rectangle is 8, and I told you the base is 4, sides have to be 2. It's like, alright, Jeff, what the shit is that? Is that calculus, Jeff? Well, it totally is. So then I can come up with, these have to be 2, right? So now watch, this gets interesting, believe it or not. If I had a function, if I had some function whose area was from A to B, let's say like this, from 0 to 8. Sorry, 0 to 4. If I knew this area was 8, stay with me, that's kind of neat if you think about it visually what's going on. Then I'm going to give you the official formula, and then you're going to go, oh, it's the same freaking thing. So how do I calculate this area? I can calculate, if I'm given the function, how do I calculate the area? How would I get the area?
F of x
What would I do to f of x to get the area?
I mean, A to B or 0 to 1.
Say the magic word. Integrate. All right. That would be A, right? That would be 8 in this case. Is that cool?
Yeah.
All right, so that's what that's saying. And now I want to know how tall, so I'm going to reposition this. So this is going to end up giving me the average function output, the average height of the function, the average of the function over the interval. Because I'm reapportioning it into a rectangle so that this would be really easy if I said, what's the average, if I put the coordinate axes like this, and so what's the average output for this function?
2.
It's frickin' 2, isn't it? Well, if it started off looking like that, And I said, what's the average? You might go, how the hell do I count? Well, no, you find the area by integrating, and then you divide by b minus a. That's the formula. It's almost too easy. In fact, how do you just tell me in English? If you had a bunch of numbers, how do you find the average?
Average.
Add them up, integrate the function, add them up. That's what integrals do, right? Add them up, divided by how much there is, and that's divided by this. That's how much there is. Almost too easy. So in this case, the average function height would be, again, it would be 2, right? So I guess it'd be a Pearson line. So let's do a concrete example, and then I'll let you guys out of here. Find average of So there's the formula. And actually, the book writes it like this.
Oh, that's, oh,
What do you do?
huh,
Add them up, divided by how many there are.
there it is.
Right? So to do this officially, so what's the average function? It's going to be integral from
1 to 3.
1 to 3, x squared minus 2, dx over 2, 3 minus 1. So when you do this, keep in mind what you're doing is you're taking whatever freakiness the function is and you're smooshing it into, so this is going to pop up, and you're smoothing it out into a rectangle. And then it's really easy to see what the average height is because it's always the same freaking height. Realize that's what you're really doing when you do this. So then you get 4 x cubed over, you're going to integrate.
Oh.
So for some reason, that's always, whenever you start doing these multi-step things, integration kind of goes away, and these just get put into there. I haven't integrated it yet. X cubed over 3 minus 2x from 1 to 3, all divided by 2.
27 divided by 3 is 9, minus 6 is 3. Over 2 is 3 halves. So minus 1 over 3 minus 2.
All over 2, so you get 3, 5 minus a third is 14 thirds, over 2 is 7 thirds. So the average of that function on the interval is 7 thirds. Whoa. It's really neat if you think about it. It's really kind of remarkably simple math to do something you would never have been able to do before chapter 5. 4. I'm trying to remember which chapter we learned integration.
Wow. That's really how easy it is. It's like, it's 2 pages.
I know, yeah, it's a very small. So I felt pretty good about doing that in 5 minutes, and actually, well, I went over some. Don't forget what's happening tomorrow. Yeah, no class. We all have no class. Tomorrow. Some of us have no class every day. No, I'm joking. No, I'm joking. So enjoy your Thanksgiving. Yeah, if you have other classes, you might want to go to them tomorrow, but I'm giving you my class off.